The Rumely 30-60 Model E, built from 1910 to 1923 by Advanced Roomley, was the company's largest and longest produced oil pull tractor, powered by a twin-cylinder, horizontal, oil-cooled engine designed for kerosene. It delivered 30 drawbar and 60 belt horsepower. This strength enabled it to pull large gangs of plows and drive industrial equipment. Its oil cooling system improved efficiency by running hotter, making the 30-60E a landmark in agricultural and construction machinery. The IH McCormick Deering 10-20, produced by International Harvester from 1923 to 1939, was one of the most successful tractors of its era, with about 215,000 units sold. Its name reflects its 10 drawbar horsepower and 20 belt horsepower, making it a practical replacement for draft horses. Powered by a 284 cubic inch engine, it featured a reliable multi-disc dry clutch with a brake pad for smoother shifting. Competing with the original Farmall, the 10-20 also had a crawler version, the Track Tractor, noted for its distinctive camel hump steering clutches. The Ursus C45, produced in Poland from 1947 to 1959, was a rugged, hot-bulb tractor. Inspired by the Lanz Bulldog, it featured a simple single-cylinder, two-stroke engine, hand-cranked after preheating, capable of running on multiple fuels, including waste oils. The Field Marshal Series 1 tractor, produced by Marshall Sons & Company, was introduced in 1945, with the 1947 version being one of the most iconic examples. It represented a major step forward in tractor design, featuring a distinctive single-cylinder, two-stroke diesel engine of around 6 liters capacity. Known for its massive flywheel, the engine generated 38 horsepower, providing reliable power for agricultural tasks at the time. The tractor was equipped with a 3-speed forward and 1 reverse gearbox, and buyers could choose between a standard 6 miles per hour or an optional 9 miles per hour top speed, depending on their needs. Weighing about 2.25 tons, it was a sturdy and dependable machine. Design-wise, the 1947 Series 1 stood out with its snub-nosed front, tall coffee percolator-style exhaust, and absence of the large air cleaner that later models carried. Painted in Brunswick green, it carried a distinctive, stylish appearance that farmers could easily recognize. The Series 1 also marked the beginning of the Field Marshal line, which later evolved through Series 2, Series 3, and Series 3A, continuing production until 1957. Overall, the Field Marshal Series 1 combined power, simplicity, and unique design, making it one of the most memorable post-war tractors in Britain's agricultural history. Howe Duck. The Roomley 30-60 Model E, built from 1910 to 1923 by Advanced Roomley, was the company's largest and longest produced oil pull tractor. Powered by a twin-cylinder, horizontal, oil-cooled engine designed for kerosene, it delivered 30 drawbar and 60 belt horsepower. This strength enabled it to pull large gangs of plows and drive industrial equipment. Its oil cooling system improved efficiency by running hotter, making the 30-60E a landmark in agricultural and construction machinery. The Lanz Bulldog 8506, often referring to the D8506 model, represents one of the most iconic German tractors of the post-war era. Produced by Heinrich Lanz AG, it featured a massive 10.3-liter single-cylinder, two-stroke Ackroyd engine, delivering 45 horsepower at 630 revolutions per minute. This engine was famous for its hot bulb ignition system, which allowed it to run on a wide range of low-grade fuels, including waste oils, making it highly adaptable for farmers in resource-limited conditions. The simplicity of its construction, with minimal moving parts, ensured durability, easy maintenance, and long service life, even under harsh working environments. Beyond its agricultural use, the Lanz Bulldog 8506 has also become a cultural icon, with miniature N-gauge collectible models produced by Wiking, featuring distinctive black engines and red rims. Its rugged design and fuel versatility cemented its place as a landmark in agricultural engineering history. The Iron Horse Nostalgia Top Fuel Dragster represents both tradition and raw power in American motorsport. Built to honor the golden era of drag racing, this machine combines vintage design with explosive performance. Its long, sleek chassis and open cockpit style reflect the look of the 1960s and 1970s. Yet under the body lies a supercharged nitromethane-fueled engine, capable of producing thousands of horsepower. During a warm-up session, the Iron Horse delivers a spectacle that excites fans and crew alike. Mechanics carefully prepare the car, priming the fuel system and checking every connection. As the engine comes to life, the roar is deafening, shaking the ground with each throttle hit. Flames shoot from the exhaust headers, while the scent of nitromethane fills the air, instantly transporting spectators back to drag racing's most iconic period. The warm-up is not simply about showmanship. It is a critical procedure to ensure engine reliability and tune-up before competition. Crew members monitor temperature, oil pressure, and fuel delivery, while the driver maintains throttle rhythm. In these moments, one can fully appreciate the blend of engineering, nostalgia, and adrenaline that makes the Iron Horse a legendary presence on the track. Drastic Plastic is Tom Motrey's legendary AAFA Nitro Dragster, built from an Anglia. Powered by nitromethane, it delivers explosive performance and the iconic gorilla flame shooting from its headers. This spectacular machine has become a crowd favorite, embodying raw power and thrilling showmanship in drag racing. At the 2015 Nitro Nationals at Cayuga, Todd Payton's top fuel dragster engine delivered an unforgettable experience. Running on nitromethane, this massive power plant produced thunderous noise and intense vibrations that shook the ground. The startup sequence alone highlighted its raw force, with flames bursting from the exhaust and a deafening roar. It was my first real taste of nitromethane, showcasing the sheer power and intensity of top fuel drag racing. The 1968 Dodge Charger fitted with a 572 Hemi engine represents the perfect fusion of vintage muscle and modern performance. This engine swap replaces the classic motor with a larger displacement 572 Hemi, capable of producing up to 780 horsepower or more. Built with custom components such as Mopar performance blocks, diamond pistons, and dual Edelbrock carburetors, the engine is designed to maximize power and reliability. To match this performance, the Charger is often upgraded with modern suspension systems like ride-tech shocks and advanced Willwood brakes, while interior enhancements improve comfort and drivability, creating an iconic yet contemporary muscle car. The blown and injected vintage 392 Hemi is a legendary Chrysler engine, enhanced with a supercharger and fuel injection system to deliver extreme performance. Originally renowned for its hemispherical combustion chambers, the 392 Hemi becomes even more powerful when blown, with forced induction and injected with precise fuel delivery. This setup dramatically increases airflow and combustion efficiency, allowing custom builds to produce anywhere from 550 to over 1,000 horsepower. Widely favored in hot rods, dragsters, and custom vehicles, the blown and injected 392 Hemi embodies raw power and vintage engineering, making it an icon in high-performance automotive history. The Mopar 383 engine is a classic big block V8 known for its strong performance and versatility in muscle cars of the 1960s and 1970s. This particular build features solid lifters, enhancing durability and high RPM stability. Bored .060 over, the displacement is slightly increased, providing additional power and improved combustion efficiency, with a compression ratio of 11.5. 1. The engine is designed for high performance, delivering strong horsepower and torque suitable for racing or street strip applications. The setup emphasizes mechanical precision, as solid lifters require regular adjustment but allow for more accurate valve control. To support this build, a homemade engine stand has been constructed, showcasing both craftsmanship and functionality, providing a stable platform for assembly, tuning, and testing. Overall, this Mopar 383 represents a blend of classic muscle engineering and hands-on customization, making it a reliable and powerful choice for enthusiasts. The Continental 0300 is a classic six-cylinder, horizontally opposed, air-cooled aircraft engine, widely recognized for its reliability. Introduced as the successor to the C145, it adopted the O designation for opposed cylinders and reflected its 300 cubic inch displacement. Producing 145 horsepower at 2,700 RPM, the 0300 was commonly used in light aircraft such as the Cessna 172. Variants including the A, C, D, and E models offer differences in crankshaft flange type, controllable pitch propeller provisions, starter drive, and vacuum pump compatibility. With direct drive design and proven performance, the 0300 became a dependable power plant in general aviation history. The Continental TSIO 520R is a six-cylinder turbocharged aircraft engine from Continental's TSIO 520 series. Known for its reliability and strong performance, it delivers up to 310 horsepower with a 7.51 compression ratio. Designed to provide efficient high-altitude operation, this engine is widely used in civil aviation. A notable application is the Cessna 210, where the TSIO 520R ensures dependable power and enhanced flight capability. Continental IO52 OB engine is a powerful and reliable aircraft engine, producing between 285 and 310 horsepower. Widely used across various general aviation aircraft, it has powered models such as the Bellanca Viking 300 and Super Viking, the Beech Bonanza and Baron, and several Cessna aircraft, including the 185, 206, 210, 310, and 400 series. Known for its durability and performance, the IO520 remained in production as late as 2019. A notable variant, the GTS IO520, incorporates propeller reduction gearing and delivers up to 375 horsepower, commonly used in twin-engine aircraft like the Cessna 404 and 421. The 10 HP Schlicker Shum slide valve engine is a fascinating example of late 19th and early 20th century gas engine design, showcasing the mechanical ingenuity of its era. This engine operates with a distinctive slide valve mechanism, which controls the admission and exhaust of fuel gases with precision. Before running, several adjustments are often made, including rescraping the slide valves, aligning the belt drive pulleys, and tuning the oilers for proper lubrication. These refinements ensure smooth performance and reliable operation. In demonstrations, this engine is commonly started on illuminating gas, a mixture of approximately 15% propane and 85% hydrogen, which provides a clean and easily ignitable fuel source. The gas is stored in a tall supply tank, while a separate hydrogen cylinder feeds the relay fan used for ignition. The hydrogen is carefully regulated to a low pressure about 5 inches of water column before being directed to the slide valve flame ports. Once the engine reaches a steady rhythm, operators can switch the fuel supply to propane, an interesting procedure that demonstrates the engine's adaptability. Propane, supplied from a standard 20-pound cylinder with a modified regulator, runs at a lower pressure of about 1 to 1.5 inches of water column, making it less demanding on the gas bag system.
In just a minute.
The engine is also water-cooled,
See what happens.
with a continuous supply of water circulating through its jacket, allowing it to run for extended periods without overheating. Watching the Schlicker Shum in operation is a vivid reminder of early gas-powered technology, combining flame ignition, slide valve engineering, and manual adjustments. It reflects both the experimental spirit and practical craftsmanship that shaped the evolution of stationary engines in industrial history.
It is running on propane now. And we're getting one hit on the governor. Sometimes. On propane, we run about 1/3 the pressure that we do on illuminating gas. so the gas bag's not as inflated. Pressure, about 1 inch of water column pressure for propane. All right, there you have it.
The 1883 Crown pumping engine is a remarkable piece of industrial history, preserved in its 100% original condition down to every screw. Built by the National Meter Company of New York City, this engine underwent a full mechanical restoration completed in June 2013, ensuring its continued functionality while maintaining historical authenticity. For display, it is mounted on a finely crafted walnut and cherry stand with cast iron legs, combining both durability and elegance. A key feature of this presentation is the dual-purpose water tank secured on the shelf. This system not only provides cooling, but also serves as a visual demonstration of the engine's pumping action, allowing observers to appreciate how it once functioned. Originally, the Crown pumping engine was designed to lift water from a basement or canal up to a cistern in the attic, making it an essential domestic and industrial utility in the late 19th century. The engine operates on illuminating gas, which at the time was widely distributed through underground city pipelines. Its flame ignition system is controlled by 2 ingeniously engineered spool valves driven by the crankshaft, showcasing the innovative mechanical design of the era.